Hi, welcome to Wise Guys. This video is on plumbing parallel offsets. It's a 45-degree offset, and I'm going to be using constants to work through this question. So here's just some information on the trig functions and the constants that are used when we're working with parallel offsets. Some people like to use the trig function, some people like to use the constants. For this video, I'm going to be using the constants. And every time we need one of these things, I'll just bring this sheet back into the page, okay? So here's our question. We have three pipes that are running vertically and had to be set off because of some problem that's right here. So the first thing I normally do is I start figuring out what's happening up here. And we can see that if we draw a line straight across here, actually that's not necessarily the first thing I do. The first thing I deal with is E, D, and C, which is our travel. So let's start there. This is a 45-degree offset, and draw a line straight across here, and the 45 degrees is here. All right, there's our 45 degrees, and our offset is the 8, and we're going to go with inches. Okay, 8 inches. So the 45 degrees is here. If we have a 45-degree triangle, these two sides of this triangle equal one another. Okay, so this is 8 inches, and this distance here is 8 as well. Okay, now when you're solving for, we can solve for this distance here, which is the travel, and we're going to use the constants. So we go back to our sheet, and it says if we want the travel and we have 45-degree offset, we take the travel and multiply it by 1.414. All right, and if you're using trig functions, you just take the travel and divide it by the sine of 45. So then what we're going to do is solve for E, solve for our travel. And let's just remind ourselves of what we're doing here. Solve for our travel, which is this piece, all right, by taking our offset and multiplying it by 1.414. All right. So this is our offset, which is 8. So the offset times 1.414. All right. So we have 8 times 1.414, which equals 11.31. All right, so E equals 11.31. And I'm not going to put the units in there. Let's just put them in. Let's go with inches. All right, now if we've solved for E, all of these sort of shifts in direction here, all of these are in parallel. All right, so because they're in parallel, E must equal D, and that must equal C. So then C equals D equals E, which equals 11.31 inches. Okay, so now the next thing that we could solve for is A. Okay, so if we're trying to solve for A, and if we want to draw a line absolutely perpendicular to this piece, which is 5 inches, okay, we draw a line straight across here, we can see then that this distance here on this pipe must be the same as here, because we drew a line straight across. So this has got to be 5. But what we want to solve for is this little piece right here, very, very tiny. This is called the difference in length, okay? Let's go back to our sheet. So the difference in length. And when we want to solve for the difference in length, we take this, and it's a 45-degree angle as an offset. We take our spread and multiply it by 0.414, okay? So now we have to figure out what that means. This distance between the two pipes is the spread. And the distance between these two pipes is 4, all right? So then, in order to find this difference in length, this one right here, so the difference in length equals the spread, which is 4, times, what did I say? 0.414. Okay, so this first difference in length then is excuse me, 4 times 0.414, which equals 1.656. Okay, so then what that means is that A is 5 plus the difference in length. So A equals 5 plus this difference in length, which is 1.656. So we end up with 6.656 inches. All right, that's the length of A. Now we can solve for B. We use the same process. We draw a line straight across from the bottom of A, perpendicular, all right? So then this distance here has to equal A. So it's got to be 6.656. And what we want to solve for is this little piece here, which is the difference in length, okay? So now for this next piece, we have B, which equals this length of A, which is 6.656, and then we add it to the difference in length, okay? So then B equals 6.656 plus difference in length here is this, yeah, let's remind ourselves again. Difference in length is the spread times 0.414 when the angle is 45 degrees, okay? So the spread here, go way down here, the spread is 6. So it's 6 times 0.414, and that equals, so we have 6 times 0.414 added to 6.656, 9.14. So B equals 9.14 inches, all right? So we've got A and B, we've got C, D, and E. Now what we need to do is solve for H, G, and F. So my approach to solving for these pieces is to think about what's happening here. We can see that from this point all the way down to here, we have 40 inches, all right? We know the distance here. We know the length of B, so we know the distance down to this point. We also know that we can drop 8 inches down here, okay? So there's 8 inches. Now if we draw a line straight across from here, okay, we can see that that's the height of H. So then H is essentially this total length, the 40 inches, minus B, and B is 9.14 inches, and then minus this distance here, which we solve for as 8. Okay, so minus the 8. So then we have 40 minus 9.14 minus 8 equals 22.86. So that's H, 22.86 inches. Now we can solve for G, all right? So G equals, now using the same process, sometimes it's a little harder to see because we're here, but if we draw a line straight down here, all the way down, okay, we can see that, and again, remembering that this total distance is 40, we can see that this distance is the distance of A. We can see that this is just the same as this, right? Only we're talking about this triangle now, right here. So here we have a distance of A. Here we have a distance of 8. All right? So if we solve for this piece right here, we've got the length of G. All right? So then G is the total, the 40 inches, minus the length of A. All right? And A was 6.656 inches. And then minus the length here, which was the 8. Okay, so G equals 40 minus 6.656 minus 8 equals 25.34. So 25.34 inches. Now, the other thing about this, we look at G, we can see G is a little bit longer than H, and our answer is longer, okay? So let's solve for F. And again, using the same process, all right? Maybe I should try a different color pen. Oh yeah, here we have a green. Okay. So again, what we're doing is thinking about this line here that's coming down from the 5, okay? Actually, maybe it might be easier just to draw this going up, okay? So we know that this distance here, again, no, that actually makes it more complicated. So we'll just draw this line right down here, okay? We're thinking about this triangle that we had. We know this distance here is 5. We think about this triangle we had here. We know this distance here is 8. All right. And we know the distance from this point all the way down to this point is 40. All right. So we have 40 from here all the way down to here. This is a 5. This distance here is an 8. So then we can solve for this distance, which is our F. All right. So then F equals the 40 minus the 5 minus this, which is the 8. And we end up with 40 minus 13, which I think is 27. 40 minus 13 equals 27. 27 inches, all right? So we have solved for everything: A, B, C, D, E, A, B, C, D, E, F, G, and H. We've got it all, okay? All right. So that is parallel offset. I hope that was helpful. And this video was brought to you by Wise Guys. Have a good day.